tonight I want to take you somewhere special, somewhere that exists all around us yet remains invisible, intangible, almost like a dream we're all sharing without knowing it. We're going to explore something that touches everything you've ever seen, every moment you've ever experienced, yet it holds a secret so profound that when Einstein first glimpsed it, he called it the most beautiful thought of his life. Tonight we're going to talk about light, and more specifically, about why it refuses to go any faster than it already does, no matter how hard we try to push it, no matter what forces we apply, no matter how much energy we give it. It's a question that might sound strange at first, something you could easily dismiss as just another quirk of physics, but the more we look at it, the more quietly intriguing it becomes, the more it whispers about the true nature of reality itself. Before we begin this journey together, I'm curious about where you are right now, in this very moment. Are you tucked into bed somewhere in London as the rain patters against your window? Perhaps you're in Tokyo, and it's already tomorrow where you are. Maybe you're in New York and the city lights are just beginning to dim outside. Whatever corner of our beautiful planet you're resting in tonight, whatever time zone cradles you, I'm grateful you've chosen to spend this time exploring these mysteries with me. And if you find yourself drifting peacefully through these ideas, perhaps feeling that gentle pull towards sleep while your mind wanders through the cosmos, consider leaving a quiet like or subscribing for more of these nighttime journeys through the universe's secrets. There's something beautiful about all of us, scattered across the earth, contemplating the same cosmic mysteries as we prepare for sleep. What if the speed of light wasn't just a number in a physics textbook, not just 297,792,458 meters per second, but a gentle doorway into understanding why the universe works the way it does? What if this seemingly arbitrary speed limit contains within it the blueprint for space, time, causality, and perhaps even consciousness itself? You see, we often think of speed limits as restrictions, as barriers, as something imposed from outside. But what if light's refusal to go faster isn't a limitation at all, but rather a fundamental feature of existence, as essential to the universe as breathing is to life? Let me take you back to a time before we knew any of this, when the world seemed simpler, more intuitive. Imagine yourself as a child, perhaps lying on grass on a summer evening, watching the stars appear one by one as darkness falls. Back then, light seemed instantaneous. You'd flip a switch, and the room would flood with brightness immediately. You'd see a lightning flash, and hear the thunder moments later, knowing somehow that light traveled faster than sound, but never really questioning why or how fast or whether there was a limit. Light just was, immediate and everywhere, like thought itself. But here's where our journey begins to take its first gentle turn into mystery. Because light, this thing that seems so immediate, so instantaneous to our everyday experience, actually takes time to travel. The sunlight warming your face right now, if you were outside during the day, left the sun's surface 8 minutes and 20 seconds ago. It traveled 93 million miles through the vacuum of space, maintaining exactly the same speed the entire journey, never slowing down, never speeding up, utterly constant in its velocity. And this is where the first whisper of strangeness enters our story. Because why should light have a speed at all? Why shouldn't it simply appear everywhere at once, instantaneously connecting all points in space? You might be settling deeper into your pillow now, perhaps adjusting your blanket, finding that perfect position for the journey ahead. Good. Let yourself relax, because we're about to explore something that challenged the greatest minds in human history, something that forced us to completely reimagine what we thought we knew about reality. And the beautiful thing is, you don't need to be Einstein to feel the wonder of it. You just need to be curious, to be willing to let your mind drift along these strange currents of thought. Consider for a moment what speed really means. When you walk across a room, you're moving at perhaps 3 or 4 miles per hour relative to the floor. When you drive a car, you might travel at 60 miles per hour relative to the road. When a plane flies overhead, it moves at 500 miles per hour relative to the ground below. But here's the key word in all of these examples: relative. All motion, all speed as we normally understand it, is relative to something else. You can only measure how fast you're going by comparing your motion to something you're passing by. This seems so obvious, so fundamental to how we experience the world, that it's hard to imagine it could be any other way. If you're on a smoothly moving train with the curtains drawn, You can't tell if you're moving or standing still without looking outside. Motion is relative. Speed is relative. Everything in our everyday experience confirms this basic truth. And yet, light refuses to play by these rules. Light moves at exactly the same speed for everyone, no matter how fast they're moving relative to anything else. This isn't just strange, it's seemingly impossible. Imagine you're standing by the side of a road and a car drives past you at 60 miles per hour. If you measure the speed of that car, you'll find it's going 60 miles per hour relative to you. But now imagine you're in another car driving in the same direction at 40 miles per hour. That same car that was going 60 miles per hour relative to the ground is now only going 20 miles per hour relative to you. This is how everything in our normal experience works. Speeds add and subtract depending on your own motion. But light doesn't do this. If you're standing still and measure the speed of a beam of light, you'll find it traveling at 299,792,458 meters per second. If you're in a spaceship traveling at half the speed of light and you measure that same beam of light, you'll still find it traveling at exactly 297,792,458 meters per second relative to you. Not faster, not slower, exactly the same speed. It's as if light exists outside the normal rules that govern everything else we've ever encountered. This discovery didn't come all at once. It emerged slowly, like dawn breaking over a landscape, revealing features that had always been there but were hidden in darkness. In the late 1800s, physicists were trying to understand how light waves move through space. They imagined that space must be filled with something called the luminiferous ether, an invisible substance that light waves could ripple through, like sound waves ripple through air or water waves ripple across a pond. It seemed logical, even necessary. How else could waves propagate through the emptiness of space? Scientists designed increasingly clever experiments to detect this ether, to measure Earth's motion through it as our planet orbited the Sun. The most famous of these was the Michelson-Morley experiment, performed in 1887. The idea was beautifully simple. If Earth is moving through the ether, then light travelling in the direction of Earth's motion should move at a different speed than light travelling perpendicular to it. Just like a swimmer in a river moves at different speeds when swimming upstream, downstream, or across the current. Albert Michelson and Edward Morley built an incredibly sensitive instrument called an interferometer. They split a beam of light and sent it in two perpendicular directions, then brought the beams back together. If the beams travelled at different speeds due to Earth's motion through the ether, they would arrive slightly out of sync, creating an interference pattern that could be measured. They rotated their entire apparatus. They repeated the experiment at different times of year when Earth was moving in different directions through space. They refined their instruments to extraordinary precision, and they found nothing. Absolutely nothing. No matter how they oriented their device, no matter when they performed the measurement, light always travelled at exactly the same speed in all directions. It was as if Earth wasn't moving through the ether at all, which made no sense because we knew Earth was orbiting the Sun. Or, more radically, it was as if the ether didn't exist, which seemed impossible because how could waves propagate through nothing? This null result, this absence of any finding, was one of the most important discoveries in the history of science. Sometimes what we don't find tells us more than what we do find. The universe was whispering a secret through this silence, though it would take a young patent clerk in Switzerland to finally hear what it was saying. You might be wondering why any of this matters, why we should care that light refuses to go faster or slower, why this cosmic speed limit should concern us as we drift towards sleep. But here's the thing. This seemingly simple fact about light contains within it the entire structure of space-time, the nature of causality, the relationship between matter and energy, even the possibility of our existence itself. When light refuses to go faster, it's not being stubborn or arbitrary. It's revealing something fundamental about the fabric of reality. Let me paint you a picture of what would happen if light could go faster, if this cosmic speed limit didn't exist. Imagine for a moment that you could accelerate light, push it to go faster just like you can push a car to go faster by pressing the accelerator. At first, this might seem like it would simply make communication faster, make the universe more connected. But the implications go much deeper, much stranger, and ultimately much more terrifying than you might expect. Without a cosmic speed limit, the concept of now loses all meaning. Think about what now means to you at this moment. You might say that now is this instant, this present moment that you're experiencing. But what about someone on Mars? What about someone in another galaxy? Without a maximum speed for information to travel, without light speed limit, there would be no way to define what simultaneous means across space. Events could happen in different orders for different observers, not just appearing to happen in different orders, but actually, fundamentally happening in different sequences, because could come after effect. The future could influence the past. The entire notion of an ordered, sensible universe would collapse into chaos. But the universe doesn't allow this chaos. It maintains order through this cosmic speed limit, through light's stubborn refusal to go any faster. And here's where Einstein's beautiful insight comes in, the thought that changed everything. What if the speed of light isn't just a speed limit, but the fundamental constant that defines the relationship between space and time? You see, before Einstein, everyone thought of space and time as separate things. Space was the stage where events happened, and time was the universal clock that ticked away the same for everyone. But Einstein realized that if light speed is constant for all observers, then space and time must be flexible, malleable, intertwined. They're not separate entities, but different aspects of a single four-dimensional fabric, space-time. When you move through space, you're also moving through time, and the faster you move through space, the slower you move through time. This isn't science fiction, it's the actual nature of reality confirmed by countless experiments. The GPS satellites orbiting Earth have to account for this time dilation, or they would give positions off by several miles within a day. Time literally passes at different rates depending on how fast you're moving and how deep you are in a gravitational field. And here's the beautiful, terrifying truth. Everything moves through space-time at exactly the speed of light. Yes, everything, including you right now as you lie there listening to these words. When you're sitting still, you're moving through time at the speed of light, but not moving through space at all. When you start to move through space, you're diverting some of that motion from the time direction into the spatial directions, which is why time passes more slowly for you. The total speed through space-time always remains constant, always equals the speed of light. Think about that for a moment. Right now, as you rest there in the darkness, you're hurtling through time at 299,792 458 meters per second. Every atom in your body, every particle of your being is racing through the temporal dimension at light speed. You can't feel it, just like you can't feel Earth spinning or orbiting the sun, but it's happening nonetheless. And when you move, when you get up tomorrow and walk around, you'll be trading some of that temporal velocity for spatial velocity, though the amount will be so tiny at walking speed that no instrument could detect the difference. This is why nothing can go faster than light through space. To do so would require moving faster than the speed of light through space-time, which is impossible because that's the fundamental rate at which space-time itself unfolds. It would be like trying to make Tuesday come before Monday, trying to make effect precede cause. The universe simply doesn't allow it because doing so would unravel the very fabric of existence. But why this particular speed? Why 299,792, 458 meters per second and not some other value? This question takes us even deeper into the mystery, into the fundamental constants that define our universe. You see, the speed of light is related to two other fundamental properties of space, the electric permittivity and magnetic permeability of vacuum. These tongue-twisting terms basically describe how easily electric and magnetic fields can exist in empty space. And here's the remarkable thing. If these values were even slightly different, if space had different electric and magnetic properties, atoms couldn't form, stars couldn't shine, and we wouldn't exist to wonder about any of this. The speed of light isn't arbitrary. It's woven into the fundamental structure of space-time, into the very possibility of matter and energy existing in stable forms. Change the speed of light, and you change everything. Make it too fast and atoms fly apart. Make it too slow, and they collapse. The universe seems to be finely tuned, with the speed of light set at exactly the value needed for complexity, for chemistry, for life to be possible. As you drift deeper into relaxation, perhaps feeling your breathing slow, your muscles releasing their last bits of tension, consider this cosmic coincidence. Or perhaps it's not a coincidence at all. We exist in a universe where light travels at exactly the right speed to allow atoms to form, stars to burn steadily for billions of years, planets to orbit in stable patterns, chemistry to create the magnificent complexity of life. Every photon reaching your eyes from distant stars, every bit of sunlight that warmed your face today, every radio wave carrying voices and music through the air, all of them traveling at exactly this special speed that makes our existence possible. There's something else about light's speed limit that's rarely discussed, something that touches on the deepest mysteries of quantum mechanics. You see, in quantum field theory, the most successful theory we have for describing the fundamental nature of reality, particles are actually excitations in quantum fields that fill all of space. The electron field, the quark field, the photon field, they're everywhere, underlying everything, and particles are like waves or ripples in these fields. The speed of light determines how quickly these ripples can propagate through the quantum fields. It sets the maximum rate at which quantum information can spread through space. Without this limit, quantum effects could be instantaneous across the entire universe, and the delicate dance of quantum mechanics that allows atoms to exist in stable configurations would be impossible. The uncertainty principle, the exclusion principle, all the quantum rules that prevent matter from collapsing or exploding, they all depend on this cosmic speed limit. Even more mysteriously, there are hints that the speed of light might be related to the nature of consciousness itself. Our thoughts, our awareness, everything we experience emerges from electrical signals traveling through our brains. These signals are electromagnetic in nature, governed by the same speed limit as light. The rate at which we can think, the speed at which we can become aware of something, the temporal resolution of our consciousness, all of it is ultimately constrained by the speed of light. Some physicists and philosophers have speculated that consciousness might be fundamentally related to the flow of information through space-time, and if that's true, then the speed of light isn't just setting limits on how fast things can move or how quickly causes can create effects. It might be setting the pace for awareness itself, determining the rate at which the universe can observe itself through conscious beings like us. As we contemplate these deep mysteries, it's worth remembering that light itself doesn't experience time. This is perhaps the strangest consequence of Einstein's revelations. From light's perspective, if we can even speak of light having a perspective, it travels instantaneously from its source to its destination. A photon emitted from a star millions of light years away experiences no time during its journey to your eye. From the photon's frame of reference, it exists for zero time, traveling zero distance, yet from our perspective, it journeys for millions of years across millions of light years of space. This means that every bit of light in the universe, every photon that has ever existed or will ever exist, experiences its entire existence in a single, timeless instant. The light from the Big Bang, the light from distant quasars, the light from the lamp beside your bed, to the photons themselves, they all exist in an eternal now, outside of time, connecting all points in space instantaneously in their own reference frame while taking finite time in ours. There's something deeply profound about this, something that touches on the nature of existence itself. We live in time, experiencing moment after moment, while light exists outside of time, connecting all moments. We're made of matter, which must always travel slower than light, which means we must always experience duration, always have a past and a future. But light, pure energy, exists in a realm beyond time. A realm we can describe mathematically but can never directly experience. This divide between matter and light, between things that experience time and things that don't, might be the most fundamental distinction in the universe. It's the difference between being and becoming, between existence and change, between the eternal and the temporal, and it all comes down to that cosmic speed limit, that refusal of light to go any faster than it already does. As you lie there in the quiet darkness, perhaps you can feel yourself existing in time, feel the moments passing one after another, your heartbeat marking the seconds, your breath marking slightly longer intervals. You're embedded in time, swimming through it at the speed of light, unable to escape its flow. But the light around you, the electromagnetic radiation from your phone, from the stars, from the cosmic background itself, it all exists in that timeless realm, touching past and future simultaneously. Scientists have tried to push light faster, to break this cosmic speed limit, using every trick they can imagine. They've sent light through special materials with negative refractive indexes. They've used quantum entanglement to try to send information instantaneously. They've looked for particles called tachyons that might naturally travel faster than light, but every attempt has failed, not because our technology isn't good enough, but because the universe itself prevents it. When light enters a material like water or glass, it does slow down, but what's really happening is that the photons are being absorbed and re-emitted by atoms, creating a delay that makes light appear to travel slower. The actual photons between atoms still travel at exactly light speed. It's like a relay race where each runner moves at top speed, but there's a delay at each handoff that reduces the overall average speed. Some experiments have created situations where the group velocity of light, the speed at which a pulse of light appears to travel, exceeds the speed of light in vacuum, or even becomes negative, appearing to exit a material before it enters. But these are tricks of wave interference, not actual faster-than-light travel. No information, no energy, nothing that could violate causality ever travels faster than that fundamental speed limit. Quantum entanglement, that spooky action at a distance that Einstein himself was troubled by, might seem to violate the speed limit. When two particles are entangled, measuring one instantly affects the other, no matter how far apart they are. But even this doesn't allow faster-than-light communication. The correlation is instantaneous, but you can't use it to send information because the results of measurements appear random until you compare them with the other particle's measurements, and that comparison can only happen through normal light-speed communication. The universe seems to have multiple safeguards against faster-than-light travel, multiple ways of preventing any violation of this fundamental limit. It's as if the cosmos is protecting itself from paradoxes, from the chaos that would ensue if cause and effect could be reversed, if the future could influence the past, if the ordered flow of time could be disrupted. But there are loopholes, at least theoretical ones. Einstein's equations allow for things like wormholes, shortcuts through space-time that could connect distant regions without requiring faster-than-light travel through space. They allow for warp drives that could contract space in front of a spacecraft and expand it behind, effectively moving the craft faster than light relative to distant objects while never exceeding light speed locally. They even allow for closed time-like curves, paths through space-time that loop back to their own past. Yet each of these possibilities comes with its own problems. Wormholes, if they exist, would likely collapse instantly unless held open by exotic matter with negative energy density, something we've never observed. Warp drives would require enormous amounts of negative energy, perhaps more than exists in the entire universe. Closed time-like curves lead to grandfather paradoxes and logical contradictions that suggest the universe would somehow prevent them from forming. It's as if the speed of light isn't just a speed limit, but a fundamental protection mechanism, a cosmic safeguard that keeps the universe consistent, logical, and comprehensible. Without it, without this refusal of light to go faster, reality itself might unravel into contradictions and impossibilities. As we drift deeper into these mysteries, consider how the speed of light connects to the other fundamental constants of nature. The strength of gravity, the charge of an electron, the mass of a proton, Planck's constant that sets the scale of quantum effects. They're all interconnected in a delicate balance that makes our universe possible. Change any one of them, including the speed of light, and the others would have to change too, or the equations that describe reality would no longer work. This interconnection suggests that the speed of light isn't really separate from the other properties of the universe. It's part of a unified whole, a single, self-consistent mathematical structure that describes everything from the smallest subatomic particles to the largest cosmic structures. We see it as a speed limit because that's how it appears to us, embedded as we are in space-time, but it might be more accurate to think of it as the fundamental rate at which reality itself processes information, updates its state, evolves from moment to moment. Some physicists have proposed that the universe might actually be computational in nature. That reality might be something like a vast quantum computer processing information at the Planck scale, the smallest possible scale in physics. In this view, the speed of light would be related to the rate at which this cosmic computation proceeds, the clock speed of reality itself. It's a wild idea, still highly speculative, but it offers a different perspective on why light refuses to go faster. It's already going as fast as the universe can process change. Whether or not the universe is truly computational, there's something deeply satisfying about the idea that the speed of light represents some kind of maximum rate, not just for motion through space, but for change itself. It means that the universe has a kind of cosmic heartbeat, a maximum tempo at which events can unfold. Nothing can happen infinitely quickly. Every change, every interaction, every moment of existence must respect this fundamental pace. This cosmic tempo affects everything, from the smallest quantum fluctuations to the largest cosmic structures. Black holes, those regions where gravity becomes so strong that not even light can escape, are boundaries defined by the speed of light. The event horizon, that point of no return, exists precisely where the escape velocity equals the speed of light. Inside, space and time become so warped that all paths lead inward toward the singularity at the center where our current physics breaks down. Even the expansion of the universe itself is governed by the speed of light, while space itself can expand faster than light, carrying distant galaxies away from us at tremendous speeds. No information, no influence can travel through space faster than light. This means there's a cosmic horizon, a boundary beyond which we can never observe or influence anything, no matter how long we wait. Parts of the universe are forever cut off from us, not because they're too far away, but because space is expanding too quickly for light to ever bridge the gap. This cosmic horizon shrinks our observable universe to a sphere about 93 billion light-years in diameter, even though the universe itself might be infinite. Everything beyond that horizon might as well not exist from our perspective, because no light, no information, no causal connection can ever reach us from there. The speed of light doesn't just limit how fast we can travel, it limits how much of the universe we can ever know. As you contemplate these vast scales, these cosmic boundaries defined by light's steadfast speed, you might wonder if the speed of light has always been the same. Could it have been different in the early universe? Might it change over cosmic time? These are questions scientists are actively investigating, looking for tiny variations in the fundamental constants across space and time. So far, every observation suggests that the speed of light has remained constant for at least the past 13 billion years across the entire observable universe. The light from the most distant galaxies, from the cosmic microwave background radiation left over from the Big Bang, it all travels at exactly the same speed as the light from your bedside lamp. The universe's speed limit appears to be truly universal, truly constant, a fixed feature of reality that has remained unchanged since the first moments after the Big Bang. But why should it be constant? Why shouldn't the speed of a light evolve as the universe expands and cools? This constancy is another mystery, another hint that the speed of light is more fundamental than just a velocity. It might be built into the very structure of space-time, into the quantum fields that underlie all matter and energy, into the mathematical framework that governs existence itself. There's a beautiful symmetry in how the speed of light connects the very large and the very small. At cosmic scales, it defines horizons and limits the observable universe. At quantum scales, it sets the relationship between energy and frequency, between momentum and wavelength. The same constant appears in Einstein's relativity and in quantum mechanics, bridging the two great theories of physics that we still struggle to unite into a single, coherent framework. This universality of the speed of light, its appearance in so many different contexts and equations, suggests that when we finally understand why light refuses to go faster, we'll understand something fundamental about the nature of reality itself. Perhaps we'll discover that the speed of light emerges from some deeper principle, some more fundamental truth about existence that we haven't yet grasped. As you lie there in the darkness, your mind drifting through these cosmic mysteries, you might feel a mix of wonder and vertigo at the implications. We live in a universe with a maximum speed, a cosmic speed limit that nothing can exceed. This simple fact shapes everything: the structure of atoms, the flow of time, the possibility of cause and effect, the nature of space itself. And light, ordinary light that seems so familiar, so everyday, is the messenger that reveals this deep truth about reality. Every photon is a testament to this cosmic limit, a particle that exists at the very edge of what's possible, traveling always at the maximum speed the universe allows. When you turn on a light, you're not just illuminating a room, you're unleashing particles that travel at the fundamental speed of causality itself. When you see a star, you're receiving messages that have traveled for years at the absolute maximum speed possible, carrying information about distant suns that might have already died by the time their light reaches your eyes. There's something both comforting and unsettling about living in a universe with such rigid rules, such non-negotiable limits. Comforting because it means the universe is orderly, predictable, governed by laws that never fail. Unsettling because it means there are absolute barriers we can never cross, speeds we can never achieve, distances we can never traverse in a human lifetime. But perhaps these limits are what make existence possible in the first place. Without the speed of the light to enforce causality, to maintain the distinction between past and future, to prevent paradoxes and contradictions, could there be any order at all? Could there be stars and planets, atoms and molecules, life and consciousness? The terrifying reason light refuses to go faster might be that if it did, we couldn't exist to observe it. In the quantum realm, virtual particles constantly pop into existence and disappear again, borrowing energy from the vacuum for brief moments before paying it back. Even these fleeting, ghostly particles respect the speed of light. They can only travel a distance proportional to how long they exist, never exceeding that fundamental speed limit. It's as if the universe is constantly checking, constantly enforcing this rule even at the smallest scales and briefest timescales. This enforcement extends to every force in nature: gravity, electromagnetism, the strong nuclear force, the weak nuclear force. They all propagate at the speed of light. When the sun suddenly disappeared, if such a thing were possible, Earth wouldn't immediately fly off into space. It would continue orbiting the missing sun for 8 minutes and 20 seconds until the change in the gravitational field reached us at light speed. Even gravity, which seems to act instantaneously in Newton's physics, actually propagates at the speed of light, carrying information about changes in mass and energy through ripples in spacetime itself. These gravitational waves, first directly detected in 2015, are perhaps the most dramatic confirmation that nothing, not even the warping of space and time itself, can travel faster than light. When two black holes spiral together and merge billions of light-years away, the resulting gravitational waves spread out through the universe at exactly light speed, eventually reaching our detectors as tiny stretches and compressions of space itself, messages from cosmic catastrophes that respect the universal speed limit even in their violence. As you consider these gravitational messengers rippling through the fabric of space-time at light speed, you might wonder what would happen if we could somehow surf these waves, ride the distortions of space-time itself. But even this wouldn't let us exceed the speed of light. The waves themselves travel at light speed, and anything riding them would still be limited by the same fundamental constraint. The universe seems to have thought of everything, closed every loophole, prevented any violation of its most fundamental rule. But there's one aspect of the universe that seems to violate the speed of a light, at least at first glance: the expansion of space itself. Distant galaxies are receding from us faster than the speed of light, not because they're moving through space that quickly, but because space itself is expanding between us and them. This isn't a violation of the speed limit because nothing is actually moving through space faster than light. Space itself is simply growing, like a balloon inflating, carrying galaxies along for the ride. This distinction between motion through space and the expansion of space itself is subtle, but crucial. It means that while we can never travel to distant galaxies faster than light, those galaxies can still recede from us at any speed. The universe can grow faster than light can traverse it, which is why our observable universe has a finite horizon, even though the universe itself might be infinite. This cosmic expansion adds another layer to the mystery of light's speed limit. Not only does light refuse to go faster through space, but it can actually lose the race against the expansion of space itself. A photon emitted from a distant galaxy might never reach us if that galaxy is receding fast enough, even though the photon is traveling at the maximum possible speed. It's like running on a treadmill that's speeding up. No matter how fast you run, you might still move backward. The interplay between light's finite speed and the expansion of space creates a kind of cosmic tragedy. There are galaxies whose light we can see now that we'll never be able to visit, even if we could travel at light speed, because they're already too far away and receding too quickly. There are events happening right now in distant parts of the universe that we'll never know about because their light will never reach us. The speed of light doesn't just limit how fast we can travel, it limits how much of the universe's history we can ever witness. Yet within our cosmic horizon, within the sphere of space-time that light has had time to traverse since the Big Bang, The speed of light connects everything. Every atom in your body has been influenced by photons from across the observable universe. Cosmic rays from distant supernovae have passed through you, contributing to mutations that drive evolution. Light from the cosmic microwave background, the afterglow of the Big Bang itself, bathes everything in a faint whisper of the universe's beginning. We are, in a very real sense, creatures of light, shaped by radiation from across space and time, all arriving at that constant, unchanging speed. The calcium in your bones, the iron in your blood, they were forged in the hearts of dying stars and distributed through space by supernova, eventually reaching the cloud of gas and dust that became our solar system. The light from those ancient stellar furnaces set the pace for how quickly those elements could spread through space, determining when and where new stars and planets could form. As your breathing deepens and your thoughts begin to drift, consider how the speed of light weaves through every aspect of your existence. The electrical signals in your nervous system, carrying thoughts and sensations, are electromagnetic in nature, limited by light's speed. The chemical bonds holding your molecules together involve electrons jumping between energy levels, emitting and absorbing photons at light speed. Even your mass, through Einstein's famous equation E or mc², is related to energy by the speed of light squared, that fundamental constant appearing again in a new context. This appearance of C2 in Einstein's equation is particularly profound. It tells us that mass and energy are interchangeable, but the exchange rate is the speed of light squared, an enormous number. This is why a tiny amount of matter can release tremendous energy in nuclear reactions, why stars can shine for billions of years on their nuclear fuel, why atomic bombs are so powerful. The speed of light doesn't just limit how fast things can move, it determines how much energy is locked inside every particle of matter. If the speed of light were different, if it were faster or slower, the balance between matter and energy would shift. Stars might burn too quickly or too slowly, or might not be able to sustain fusion at all. The delicate balance that allows stars to shine steadily for the billions of years needed for life to evolve would be disrupted. Once again, we find that light's specific speed, its refusal to go faster or slower, is essential for our existence. In the realm of quantum field theory, the speed of light appears in even more fundamental ways. It sets the relationship between space and time in the quantum vacuum, determining how virtual particles can fluctuate into existence. It appears in the uncertainty principle, relating the uncertainty in energy to the uncertainty in time. It governs how quantum fields can interact, how particles can be created and destroyed, how the fundamental forces of nature operate at the smallest scales. Some physicists believe that at the Planck scale, the smallest possible scale in physics, space and time themselves become quantized, discrete, like pixels in reality's display. At this scale, about 10^35 meters and 10^44 seconds, the speed of light would represent the fundamental rate at which these pixels can update, the maximum speed at which information can propagate through the quantum foam that might underlie space-time itself. If this picture is correct, then light's refusal to go faster isn't just a rule imposed on things moving through space-time, it's a reflection of the granular nature of space-time itself. Just as you can't make a video play faster than its frame rate allows, you can't make anything move through space-time faster than the rate at which space-time itself updates. The speed of light would be the refresh rate of reality, the cosmic clock speed that governs all change and motion. This idea remains highly speculative, at the very edge of theoretical physics, but it offers a tantalizing glimpse of why light behaves as it does. Perhaps light travels at the maximum possible speed because it's riding the wavefront of causality itself, surfing the leading edge of each moment as it becomes the next. Perhaps photons are the universe's way of propagating change at the maximum possible rate, messengers that carry information about what has happened to influence what will happen. As you sink deeper into relaxation, your conscious mind beginning to yield to the approach of sleep, you might sense yourself embedded in this vast web of light-speed connections. Every photon reaching your eyes, every radio wave passing through your body, every gravitational ripple from distant cosmic events, they all connect you to the broader universe, all traveling at that same fundamental speed that refuses to be exceeded. The constancy of light speed across all of space and time means that, in a sense, there's a universal framework, a cosmic stage that all observers share even if they disagree about the timing and spacing of events. This framework, this space-time manifold that Einstein revealed, is held together by light, defined by light, made coherent by light's stubborn insistence on travelling at exactly one specific speed. Without this constancy, without this refusal of light to go faster when pushed, or slower when pulled, there could be no unified description of reality. Every observer would live in their own disconnected universe, unable to communicate meaningfully with others about what they observe. The speed of light doesn't just connect different parts of space, it ensures that all observers, no matter how they're moving, can share a common reality, can agree on the laws of physics even if they disagree on specific measurements. This is the deep democracy of the universe, the principle of relativity that says no observer is special, no reference frame is preferred, and it all stems from light speed being the same for everyone. If light travelled at different speeds for different observers, some reference frames would be special, there would be a preferred cosmic rest frame, and the beautiful symmetry of Einstein's relativity would be broken. But the universe maintains this symmetry, enforces this democracy, through the constancy of light speed. And this has profound implications for how we understand space, time, matter, energy, and perhaps even consciousness itself. We are not separate from the universe, observing it from outside. We are part of it, embedded in it, governed by the same laws and limits that govern everything else. The terror in light's refusal to go faster isn't that it limits us, but that it reveals how fundamental these limits are. We can't escape them because they're not external constraints but part of the very fabric of existence. We are made of atoms held together by electromagnetic forces propagating at light speed. We think with brains that process information through electrical signals limited by light speed. We exist as patterns of matter and energy in a space-time whose structure is defined by light speed. Yet there's also a deep beauty in this integration, this unity between us and the cosmos. The same light that carries information across the universe carries the signals in our neurons. The same electromagnetic force that holds atoms together powers our technology. The same relativistic effects that govern black holes and neutron stars operate in the GPS satellites that help us navigate. We're not separate from the cosmic dance. We're part of it, participants in the same light-speed symphony that plays throughout the universe. As sleep approaches, as your thoughts become less directed and more dreamlike, you might feel yourself dissolving into this cosmic unity. The boundaries between self and universe become less distinct. You are patterns of matter and energy, temporary arrangements of particles that themselves are excitations in quantum fields, all governed by the same fundamental constants, all respecting the same speed limit that light itself cannot exceed. In your dreams tonight, you might fly between stars, travel to distant galaxies, explore realms beyond our cosmic horizon. In the freedom of sleep, you're not bound by the speed of light. But even in dreams, even in imagination, we carry with us the intuitions shaped by living in a light-speed limited universe. Our sense of cause and effect, of time flowing forward, of distances that must be traversed, these are all gifts of light's finite speed. Tomorrow, when you wake, the morning sunlight will have travelled 8 minutes from the sun to reach your window, carrying energy that started as fusion in the solar core possibly millions of years ago, slowly working its way to the surface before racing through space at that constant, eternal speed. The light will scatter through Earth's atmosphere, painting the sky blue, reflecting off surfaces to reveal the world around you, all at 292,158 meters per second, never faster, never slower. And in that consistency, that refusal of light to be rushed or delayed, lies the stability of existence itself. Atoms remain stable because electrons orbit at speeds much less than light. Chemistry works because molecular bonds can form and break at reasonable rates. Life exists because DNA can replicate, proteins can fold, cells can divide, all at speeds far below the cosmic limit, leaving room for the complexity and variety we see around us. If light could go faster, if there were no cosmic speed limit, this room for complexity might not exist. Everything might happen at once, instantaneously, without the time for intricate processes to unfold. The universe might be a flash of existence rather than a long, slow story spanning billions of years. The terrifying reason light refuses to go faster might simply be that without this refusal, there could be no story at all, no time for galaxies to form, stars to evolve, planets to cool, life to emerge, consciousness to awaken. We exist in the space between zero and the speed of light, in that finite realm where time passes, where causes lead to effects, where change is possible but not instantaneous. This is our home, this slice of space-time where things can happen but not too quickly, where information can travel but not infinitely fast, where we can influence our surroundings but only within the light cone of causality, extending from each moment of our existence. As you drift closer to sleep, feeling perhaps the weight of your blankets, the softness of your pillow, the gentle rhythm of your breathing, remember that even these simple sensations are gifts of light's finite speed. The pressure you feel is atoms pushing against atoms, electromagnetic forces operating at light speed. The warmth you feel is infrared radiation, photons carrying energy at that same cosmic pace. Even the darkness behind your closed eyelids is defined by the absence of photons, by light choosing not to be there. We swim in an ocean of light, visible and invisible, radio waves and microwaves, infrared and ultraviolet, X-rays and gamma rays, all traveling at the same speed, all refusing to go faster no matter their energy or frequency. This electromagnetic spectrum, this rainbow that extends far beyond what our eyes can see, carries all the information we receive from the universe beyond our immediate touch. And it all travels at that one special speed, that cosmic constant that defines the rate at which reality unfolds. Perhaps one day we'll understand more deeply why light behaves as it does, why this particular speed and not another, why the universe chose this specific value for its fundamental tempo. Perhaps we'll discover that it emerges from some deeper principle, some more fundamental truth about existence that we haven't yet imagined. Or perhaps the speed of light will remain a mystery, a given fact about our universe that we must simply accept, like the existence of existence itself. But for tonight, as you prepare to cross the threshold into sleep, you can rest in the knowledge that light's refusal to go faster isn't a limitation but a foundation. It's what makes the universe comprehensible, what allows causes to precede effects, what enables the slow dance of cosmic evolution that eventually produce stars, planets, and the quiet miracle of consciousness contemplating itself. The photons streaming from distant galaxies, carrying news of cosmic events from millions of years ago, they're traveling as fast as the universe allows, bringing us messages from across space and time at the maximum possible rate. And yet this maximum is finite, limited, achievable. Light doesn't struggle to maintain its speed. It simply travels at the only speed it can, the natural pace of electromagnetic waves through the vacuum of space. There's something deeply peaceful about accepting this cosmic speed limit, about recognizing that we live in a universe with boundaries, with rules, with structure. We're not adrift in chaos, but embedded in order, even if that order includes mysteries we don't yet understand. The same laws that govern the farthest galaxies govern the atoms in your body. The same speed limit that constrains starlight constrains your thoughts. We're part of a unified whole, a cosmos that makes sense even in its strangeness. As consciousness fades into the soft darkness of sleep, as your thoughts become less coherent and more dreamlike, you remain part of this light-speed universe. Your sleeping brain will continue its electrical dance, processing the day's experiences, consolidating memories, all through signals traveling at a fraction of light speed through your neurons. Your heart will continue beating, regulated by electrical impulses. Your cells will continue their metabolic processes, all governed by the electromagnetic forces that propagate at that fundamental cosmic rate. Even in sleep, even in the deepest dreams, you remain connected to the cosmos through light. Photons from your body's heat radiation stream out into space, carrying information about you into the universe. Most will be absorbed by your blankets, your walls, the atmosphere, but some might escape Earth entirely, traveling outward at light speed, carrying a faint signal of your existence to the stars. And from those same stars, from galaxies beyond counting, from the cosmic web that spans the observable universe, light continues its journey toward Earth, toward you, at that constant, reliable speed that refuses to be exceeded. Some of those photons have been traveling for billions of years, maintaining exactly the same speed across all that time and distance, faithful to the cosmic speed limit that makes their journey possible. Tonight, as every night, you rest at the intersection of countless light rays, a node in the electromagnetic web that connects all things. You are both source and receiver, sending out your own radiation while absorbing energy from your surroundings, all mediated by photons traveling at the speed of light. You are part of the conversation the universe has with itself, conducted entirely through messengers that refuse to exceed that fundamental speed. And perhaps that refusal is not terrifying at all, but comforting. It means the universe is predictable, that causes precede effects, that the future emerges from the past in an orderly way. It means we can understand the cosmos through observation and reason, that the laws we discover here on Earth apply everywhere, that we're not isolated but connected to everything we can see, and much that we cannot. The speed of light is our window into the fundamental nature of reality, a constant that appears in equation after equation, linking seemingly unrelated phenomena. It connects space to time, matter to energy, electricity to magnetism, gravity to the geometry of space-time. It appears in quantum mechanics and general relativity, in thermodynamics and particle physics. It is perhaps the most fundamental constant we know, the one from which others can be derived, the cornerstone of our understanding of the physical world. And it all comes down to light's simple refusal to go faster than 297,458 meters per second. This number, precise and arbitrary seeming, contains within it the secret of existence. Change it, and atoms fall apart or collapse. Change it, and stars can't shine. Change it, and the delicate balance that allows complexity, life, and consciousness becomes impossible. We exist because light travels at exactly the speed it does, no faster, no slower. We think because electrical signals in our brains respect this speed limit. We see because photons journey from objects to our eyes at this precise velocity. We are, in every sense, creatures of light, beings that exist only because the universe has this particular speed limit, this specific boundary that shapes everything. As sleep finally takes hold, as your last conscious thoughts dissolve into the beginning of dreams, you can release any fear about light's cosmic speed limit. It's not a cage, but a foundation, not a restriction, but an enabler. It's what allows the universe to exist in a form where consciousness can emerge to contemplate it, where beings like us can wonder about the nature of light and space and time. The terror of light's refusal to go faster transforms into wonder when we realize that this refusal is what makes wonder itself possible. Without it, without this fundamental constant that governs all electromagnetic phenomena, there could be no stable atoms to form our bodies, no steady stars to warm planets, no time for evolution to craft complex organisms, no possibility for brains that can think about thinking. Tomorrow the sun will rise, its light reaching you at the same speed it has always traveled, the same speed it reached our ancestors, the same speed it will reach our descendants. This constancy across time and space is a gift, a promise that the universe operates according to comprehensible laws, that what we learn today will still be true tomorrow, that our understanding, however incomplete, touches something real and lasting about the nature of existence. And now, as you drift into sleep, you can release all these thoughts, all these wonderings about light and speed and cosmic limits. Let them float away like photons into space, traveling at their ordained speed, carrying their information into the darkness. You've traveled far tonight, from the everyday experience of light to the deepest mysteries of space-time, from Einstein's insights to the quantum foundations of reality. But now it's time to rest, to let your consciousness slow below light speed, to enter that realm of dreams where the normal rules don't apply, where you can fly faster than light if you wish, where time can flow backward or stop entirely, where the impossible becomes possible. Your sleeping mind needs no permission from physics to explore impossible worlds. The speed of light only governs the waking universe, not the universe of dreams. Yet even in sleep, you remain part of the physical cosmos, made of atoms obeying the laws of physics, including light's steadfast speed limit. Your sleeping body continues its biological processes, all mediated by electromagnetic forces, all respecting that fundamental constant. You are simultaneously a dreaming mind free from physical constraints and a physical being embedded in the light-speed-limited universe. This duality, this existence at the boundary between thought and matter, between imagination and physics, is part of what makes us human. We can conceive of faster-than-light travel even though we're bound by light's actual speed. We can imagine violating the laws of physics even as we're completely subject to them. We can dream of impossibilities while our very ability to dream depends on the universe's strict adherence to its fundamental rules. So rest now in this beautiful paradox, this tension between freedom and constraint, between imagination and reality. Let the speed of light stand guard over the universe while you sleep, maintaining the order that allows disorder, the rules that enable freedom, the limits that make limitlessness conceivable. The photons continue their eternal journey at exactly 297,792,458 meters per second, no faster, no slower, carrying their messages through space and time. Gravitational waves ripple outward from distant catastrophes at exactly the same speed. The electromagnetic forces holding your atoms together propagate at this precise velocity. Everything in the universe that carries information, that mediates forces, that connects cause to effect, respects this absolute limit. And in the quiet, darkness of your room, as sleep deepens its hold, you are held safely within these cosmic constraints. The same speed limit that prevents paradoxes prevents the universe from flying apart. The same restriction that limits how fast you can travel ensures that atoms remain stable, that chemistry works, that life is possible. The terrifying reason light refuses to go faster has become a lullaby, a cosmic reassurance that the universe makes sense, that reality has structure, that existence is possible because of limits, not in spite of them. The speed of light is not our enemy but our foundation, not our prison but our home. Sleep now, carried by the same cosmic forces that carry light across the universe, embedded in the same space-time that light reveals through its constant speed, part of the same reality that exists because light refuses to go faster. In your dreams, you're free to break every law of physics, to travel instantly across the universe, to reverse time itself. But your sleeping body remains faithfully here, in this light-speed-limited cosmos, waiting for tomorrow's photons to wake you with their ancient constant journey from the sun. The universe continues its patient unfolding at the pace set by light, neither rushing nor delaying, simply being and becoming at the only rate it can. And you, small pattern of matter and energy, temporary arrangement of particles and forces, you are part of this cosmic patience, this steady progression from moment to moment at the speed of light through time. Rest well in this knowledge, in this deep connection to the cosmos. You're exactly where you need to be, traveling through time at exactly the right speed, embedded in a universe whose speed limit makes your existence possible. The light refuses to go faster so that you can exist to wonder why. And as you drift into sleep, into that realm where time becomes elastic and space becomes optional, remember that you'll return to the light-speed universe in the morning to find it exactly as reliable as you left it. Photons still racing at their cosmic speed limit, still refusing to go faster, still maintaining the delicate balance that allows stars to shine, atoms to hold together, and conscious beings to wake up and wonder at it all. The mystery remains, wrapped in equations and observations, but never fully explained. Why this speed and not another? Why does light refuse to go faster? The answer whispers through every photon, every electromagnetic wave, every moment of existence, because this is the speed at which reality itself unfolds, the rate at which the possible becomes actual, the pace at which the universe writes its own story. And you are part of that story, written in light-speed signals, quantum uncertainty, and cosmic evolution. Sleep now, and let the universe continue its light-speed dance around you, through you, within you. Tomorrow you'll wake to find it still there, still constant, still refusing to exceed its fundamental limit, still making existence possible through its beautiful, terrifying refusal to go any faster. In the silence between stars, in the darkness between photons, in the pause between heartbeats, the universe continues its patient becoming at the speed of light. And as you drift into sleep, you remain part of this quiet universe, wrapped in its laws, carried by its mysteries gently, peacefully into the night. End.